Welcome back to Academia Biology and it's me Sachin Antil. So guys, in body fluids and circulation we have done with the internal structure of heart, and today we are going to start with the circulation of blood. So guys, we have various type of circulation in which we are going to study double circulation. Double circulation, and your double circulation consists of two circulations. The first one is the pulmonary circulation. Pulmonary circulation, and the second one is systemic circulation. Systemic circulation. But then beside this, we have some other types of circulation. Special type of circulation. Special types of circulation. Or we can say the circulation through special reasons. So this part contains, the second is coronary circulation. Coronary circulation. Then third is fetal circulation. And the last but not least is the portal circulation. In portal circulation, we are going to study two portal systems. First is the hypophyseal portal system. And the second is the hepatic portal system. So guys, in today's lecture we are just confined with the double circulation only. So now let's start with double circulation. The remaining other types of the circulation will be dealt in the next lecture. So guys, as I have just mentioned that your heart is a conical shaped structure. So suppose this is the structure of your heart, and it is divided in this way into four chambers. This is your right atrium. So guys, as you have earlier aware about this, that your right atrium receives deoxygenated blood from your body, and mainly three veins are present to carry the deoxygenated blood from the body to your right atrium. And the three veins are, suppose this is your body, it's just an imaginary body, we can say. Suppose this is your body, and as I have already mentioned that the deoxygenated blood is carried by veins, and we are going to represent the veins with blue color. Suppose this is a vein from your body that is carrying the deoxygenated blood towards your right atrium. For to carry the deoxygenated blood from your body to the right atrium, we have three veins. The first one is, this is the upper vein. This is your superior vena cava. Superior vena cava. And we also call it as precaval. Precaval. Then the opening of the superior vena cava is here. Then the second vein that carry deoxygenated blood from your body to your heart is your inferior vena cava, and the opening of your inferior vena cava is here. Then beside these two veins, we also one thing also present that carry deoxygenated blood, that is your coronary sinus. So guys, now let's see what is coronary and what is coronary sinus. Coronary simply refers in regarding to your heart. Anything that is related to your heart is regarded as coronary. As you know, your heart is also an organ, so it also needs blood supply. A continuous blood supply is also needed by your heart. So the oxygenated blood is carried towards your heart by coronary arteries, and the deoxygenated blood from your heart is taken back by the help of coronary veins. So these are for your heart, therefore we call them as coronary arteries and coronary veins. So all the veins united to form a big vessel called as coronary sinus, that is carrying all the deoxygenated blood from your heart to the right atrium. So this is your coronary sinus. Coronary sinus, and this vein was your inferior vena cava. Inferior vena cava. Inferior vena cava. And we also call this inferior vena cava as post cable. So guys, all these three things carry the deoxygenated blood from your body and from your heart into the right atrium. So here you have find one thing. After filling of the blood into the heart, there are chances of the regurgitation of the blood into the inferior vena cava. So to prevent the backflow of the blood into the inferior vena cava, we have certain mechanisms. There are two mechanisms to prevent regurgitation. First is the pressure inside your post cable vein is greater than your right atrium. The pressure inside your post cable vein is greater than your right atrium. That prevents the backflow. Pressure is greater in post cable in comparison to your right atrium. Then the second mechanism to prevent the backflow into your inferior vena cava is that as your heart's chamber, that is your right atrium, is filled with blood and it starts to contract. On that time, the walls of your heart starts to contract. The walls or the muscles of your heart wall that are present in here, the opening of the inferior vena cava starts to contract and completely closing the opening so that the blood can't enter into the inferior vena cava. So guys, in this way we have two mechanisms: contraction of muscles of heart wall near opening of post cable. So by these two mechanisms, the backflow of the blood into the inferior vena cava is prevented. So guys, then also here one important thing comes. Your post cable vein during the fetal life, it contains a valve, and the name of this valve is eustachian valve. Here we got a valve during fetal life, and the valve is eustachian valve. But as the fetus grow and it become mature, on the course of that time the valve get disappear, or we can say regress. Only the remnant of that valve is found there. So it's not functional in the adult. So there is no functioning of the valve in the adult. But in some books you can find that the valve is functional and the valve prevent the backflow, but it is not so. To prevent the backflow we have these two mechanisms only. So here we got a valve, and in case of superior vena cava, due to its position the backflow of the blood is not possible there, so we don't have a valve there, and there is no need of any valve at the opening of the superior vena cava. Then here we go the coronary sinus. In the coronary sinus there is chances of backflow of blood, so here we got a valve, and the valve is called as Thebesian valve. Thebesian valve. This is Thebasian, Thebesian valve for coronary sinus. Then suppose the deoxygenated blood from your veins enter into your right atrium. Then from the right atrium the bloods need to be enter into your right ventricle. This is your right ventricle. Right ventricle. From the right ventricle the blood will move inside your right ventricle. The blood from right atrium will move into your right ventricle through tricuspid valve that we got here, as we have discussed in the previous lecture. So through the tricuspid valve the blood from the right atrium enter into the right ventricle, and from the right ventricle the blood enters into another valve. Here we got a valve. This valve is called as pulmonary valve. This is a pulmonary valve. Pulmonary valve. And also we call it as semilunar valve. Semilunar valve. We call this pulmonary valve as semilunar valve because this valve is made up of three moon-like flap-like structure. Because this is made up of three moon-like structure, that's why we call it as semilunar valve. So guys, from the right ventricle, the blood will enter through the pulmonary valve into the pulmonary artery. The blood will enter into the pulmonary artery. Suppose this is your, I am erasing this coronary sinus part, and suppose this is your pulmonary artery. So guys, the pulmonary artery is carrying the deoxygenated blood, and after this the pulmonary artery will divide into right branch and a left branch. The right branch will carry the blood towards your right lung, and the left branch will carry the blood towards your left lung. So the blood is taken from the right ventricle by entering into the pulmonary artery towards the lungs for oxygenation. Suppose we have lungs here. These are our lungs. And the blood is taken here. And the blood is taken here for oxygenation. And this is your pulmonary artery. Pulmonary artery. Then after reaching into the lungs, the pulmonary artery will form capillaries, and by the help of capillaries the exchange of gases will take place at the level of alveoli. The carbon dioxide from the blood will move out of the blood into your alveoli, and the oxygen from the alveoli move inside your blood. So guys, in this way your blood get oxygenated, and after oxygenation the pulmonary arteries form capillaries, and then the capillaries will unite to form your pulmonary veins. And the pulmonary veins will take the oxygenated blood to the left atrium. Left atrium. This is your left atrium, and here we got pulmonary veins. And one thing that is, there are two pairs of pulmonary veins, something like that, and these also have two branches. These are your two pairs of pulmonary veins having two branches in this way. So these are your pulmonary veins. These are your pulmonary veins. So guys, one of the important thing is that the pulmonary artery is the only artery after birth that is carrying the deoxygenated blood. Normally I have said the arteries are for the transport of oxygenated blood from the heart to your body parts. But in this case, the pulmonary artery is carrying the deoxygenated blood from your heart to your lungs for oxygenation. At the level of lungs, oxygenation takes place. Oxygenation takes place, and after oxygenation, the capillaries will unite to form pulmonary veins, and the pulmonary veins are carrying the oxygenated blood, and these are also the only veins that are carrying the oxygenated blood. These are carrying only veins after birth. After birth that carry oxygenated blood. Oxygenated blood. The pulmonary veins are the only veins after birth that carry oxygenated blood. But in normal cases, the veins are usually help in transfer of the deoxygenated blood. This is a very important point. Pulmonary veins carry oxygenated blood. And similar here in the case of pulmonary arteries. Only arteries after birth that carry deoxygenated blood. Deoxygenated blood. The special thing is here, it is that the arteries are usually helpful in carrying the oxygenated blood, but here the arteries are carrying the deoxygenated blood. So it is very important to keep it in mind that the pulmonary arteries are carrying the deoxygenated blood. So I think you have understood all the story up till here. This is your left atrium. So guys, your pulmonary veins also doesn't need any type of wall. Because of their position, the backflow of the blood is not possible. Then from here, the oxygenated blood will enter into your left atrium. From your left atrium, the blood must enter into the left ventricle, and the transfer will done through the valves called as bicuspid valve. As in the previous lecture we have discussed, here we got bicuspid valves. Also we call it as mitral valve. So the blood from your left atrium through the bicuspid valve enter in your left ventricle. This is your left ventricle. And one important thing about your left ventricle is that it is the thickest chamber of your heart. Thickest chamber of your heart. Chamber of heart. It is thickest because it needs to pump the blood throughout your body. So guys, from left ventricle, the blood through the semilunar valve. Here we also get a semilunar valve called as aortic valve. This is your aortic valve. Aortic valve, which is also a semilunar valve. It's also a semilunar valve. Semilunar valve. So the blood from the left ventricle through the semilunar valve, aortic valve, reach into the descending aorta. Here we got a blood vessel, and the name of the blood vessel is, and this is your aorta. This is your aorta. So the blood will reach into the aorta. This is aorta. So what is the scenario after this aorta? So now let's see. This is your aorta, and the blood have been flowing into your aorta. That means the blood has reached from your left ventricle into the aorta. Then the blood have two things to do. Some part of the blood from aorta move to your coronary arteries. Coronary arteries. And the coronary arteries supply blood to your heart itself. Coronary arteries will supply blood to your heart itself. To your heart itself. And the remaining part of the blood will enter into systemic aorta. And the systemic aorta will supply blood to your body. So from here, some part of the blood move to your coronary arteries, and the remaining part will enter into systemic aorta. So suppose behind this we have systemic aorta like this. This is your systemic aorta that is carrying the oxygenated blood to your body. This is systemic aorta. And this curved part is called as arc of aorta. This is your arc of aorta. So guys, this is looking so much complicated. So to remove the complications, I am adding an extra line into your aorta that is of green color, which is presenting that the blood is oxygenated. So this systemic aorta is taking the oxygenated blood to your body parts. And from body, after the blood get deoxygenated, means the carbon dioxide level of the blood have been increased. Then the veins carry the deoxygenated blood to your right atrium of the heart. So guys, this is the story of your blood circulation. So here, where is the pulmonary circulation and where is the systemic circulation? So guys, have a look at this. The blood that is present in the right atrium enter into the left ventricle, and then it is carried by the pulmonary artery to the lungs. This part of the circulation is called as your pulmonary circulation. देखो, So guys, look, the deoxygenated blood from the body is carried to your right atrium, and from right atrium by moving into the left ventricle it moves into your pulmonary artery. So this circulation up to the level of your lungs, this is your pulmonary circulation. And then after the blood get oxygenated, it will reach into your left atrium, and then from the left atrium the blood is circulated your throughout body. So this part of your circulation is your systemic circulation. So we can say the circulation towards this side is your systemic circulation. Systemic circulation. And the part of your circulation towards this side is your pulmonary circulation. Pulmonary circulation. So guys, I have mentioned all the important things that are necessary to learn and to keep in mind. So this is your circulatory pathway of your blood. Then the remaining type of circulation we will discuss in the next time. If you have any doubt regarding this topic, then you can ask me in the comment section. So guys, thank you for watching me carefully and stay tuned for the next one.